This is the video lecture for week 7. Here we discuss the application of differentiation, means how we use the idea of differentiation in solving practical problems. Here we discuss two applications of differentiation, one linear approximation, two Newton's method. Let's start with linear approximation. You are given x naught, then we can always find the equation of the tangent at x naught, whose equation is given by this formula. So this is the linear approximation for finding f of x1, where this x1 is close to x naught. So this is the linear approximation formula to find f of x1, where x1 is close to x naught, where x naught, f of x naught is given. Let's take an example. This is the formula. The linear approximation of fx at x is equal to x naught is given by this, and it is also called equation of the tangent line. Let's find the linear approximation to this function at this point. And then the same thing we will use it to find or approximately find the cos of 1. So here x naught is given pi by 3. Then we use this formula and we substitute this. And to find f prime x naught, I need to find f prime x. So derivative of fx is this. Then I substitute all these values here. You get L of x is equal to cos pi by 3 minus sin pi by 3 x minus pi by 3. So find the value of this and this by calculator using the radian mode, then I get this. So this is the linear approximation of cos x at x naught equal to pi by 3. And we use this to find cos of 1. So this is x1 in fact, that is 1, and this is x naught, which is pi by 3. This pi by 3 and this one are very close. Therefore, I can use this formula. So what I will do, I will just put this x is equal to 1. So it is cos 1 or L of 1. So this x I put 1, then I get this. So this is the approximate value from this linear approximation. So use the calculator to find the exact value. Compare this with this, it is close to this. Another example. Find the linear approximation of sin x for x close to 0. So this is x naught. So f prime find for this, and then put x naught equal to 0 in the formula. So Lx, that means sin x, is this. Then substitute x is equal to 0, and I get this. Simplifying, I get this. So Lx is equal to x or sin x is equal to x is the linear approximation of sin x for x equal to 0, that is close to 0. Another example. Here we are given table, not function, and you are asked to find, see, x is the price, fx is the small cameras, that is the number of small camera, and you estimate the number of camera, that is find f when x is equal to 7. So here x naught is not given, so you have to choose x naught. So you choose, there are three values of x here, 6, 10 and 14. So choose closest to this 7, that is what you are asked to find. So the closest x value to x is equal to 7 is 6. So this 6 is x naught. So substituting x naught equal to 6 in the formula, that is linear approximation, you have this. Note that f of 6 is 84, but f prime 6 is not given, and we cannot find because the function is not given. So we approximately find f prime 6. So this f prime 6, which is the equation of the tangent line. So note that equation of the tangent line we cannot find. That means we cannot find f prime x because fx is not given. So we approximately find this. For that I will use the slope of the secant line. So approximately I write, so f prime a is fb minus fa. So this will be a, this will be b. So fb minus fa, b minus a. So f10 and f6 is from the table, so 60 minus 84. Then I divide it. So this is f prime 6. Substituting this here, we get this. So this is the linear approximation for what you call to find any value of x for x value. But this x is equal to 7, which we are asked to find. So this x I substitute equal to 7 in this formula, I get this. Then we have second application of derivative, that is called Newton's method. So note that for this what we call quadratic function, we can factor it and we can find the zeros or the roots, and or we can use formula to find the roots of this quadratic equation. Suppose if we are asked to find the zeros or the solution of this transcendental equation, it is not possible because there are no formulas for this. So what the Newton's method does is, it gives you the zeros of such transcendental functions where there are no formulas. So clearly we see here that the Newton's method is used to find the zeros of a function. What do you mean by zeros of a function? The value of x such that fx is equal to 0 are called roots of the zeros of the function fx is equal to 0. So this is the Newton's formula. Xn plus 1 is equal to xn minus f of xn f prime xn for n equal to 0, 1, 2, 3, etc. That means first I put n equal to 0. So this becomes x1 equal to x0 minus f of x0 f prime x0. So that is the first approximation. Then I put n equal to 1. Then this becomes x2, this becomes x1, 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 second approximation. Then I put n equal to 2. This becomes x3, x2, 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 third approximation. So these are called, that's why it is known as successive approximation. So using this Newton's formula, we will be finding the successive approximation for the function fx is equal to 0. And this successive approximation is for the roots or the zeros of the function fx is equal to 0. Let's see an example. Find the approximate zero of this, that is fifth degree equation. Of course, there are 5 roots here and we will be finding one of it. So what we do now, we have to now start with guess value, I mean the value where the roots exist. So what we will do, we just substitute randomly two values. So I put x is equal to -1, we get positive. Then I put x is equal to -2, I get negative. So you should get two values, you have to substitute, one positive, one negative. So when we have this, according to intermediate value theorem, f must have a 0 in this interval, that is -1 and 2, that is -2 is lesser, so -2 comma -1. So your solution or your 0 for this equation must be lying between -2 and -1. So I can start the initial guess or initial root or initial 0 as -1. So we have fx, find the derivative till this, then this is the formula. So what we do here is this f of xn, so this is f of x is this, so f of xn means I just replace this x by xn. So I have this. F prime x is 5x4 minus 1. I replace x by x1. So we have this. So this is what the Newton's successive approximation formula for n0, 1, 2. So what we do, we just substitute n equal to 0. So I get x1. So we started with x naught equal to minus 1. We substitute. We see xn, that means this xn, this xn, this xn becomes x0. I substitute as minus 1. Then I simplify this. I get minus 5 by 4. Then this will be your x1. So that now I put n equal to 1. So you get x2. And all the right hand side becomes x1. So this x1 is minus 4. So look at it. This, instead of minus 1, I am substituting minus 5 by 4. That is the previous value. You see, for x1 I use minus 1. The x2 I will use minus 5 by 4. I simplify this, I get this. For x3 I put n equal to 2. Then I will use this value in the next one. So if you see that x3 will be this, and x4 will be this, and x5 will be this, etc. We have another example where you are asked to find the approximate value of 3 cube 7, not using the calculator, by using the Newton's method. So look at it. We have to just make this equation, because there is no equation. In the Newton's method we need an equation. So what I will do, I will just equate x is equal to this. Then I take cube root both sides. So x cube is equal to 7. So this is your what you call equation. So we will take the derivative this, and then we have to take the initial guess here. So initial guess, what happens that we take x is equal to 2, because 2 cube, that is 8 minus 7, it is 1, it is close to 0. So therefore I can take x not equal to 2. So I will just use the same Newton's method, and the first approximation will be, I will use this as my initial guess, it is this. For the second I will use this. For the third I will use this. Like that I find this. So this value, use the calculator, check that this is the approximate value by Newton's method, and use the calculator and compare this value with the actual value. So remember here, in using the Newton's method, we have to be very careful in choosing this x naught value. Then these are the examples which I will be doing in the live class, and these are all linear approximation which we have already done. So these are what you call examples without what you call function, and this is the Newton's method, and this is another example. So these examples we will be doing in the live class, more details. So these are the answers. And what we have studied in the first video lecture of week 7, the two application of derivative. One is linear approximation, and another is Newton's method to find the roots or the zeros of a function. So the next part we will take up the second part of this week number 7. Thank you.